난 모를 거야. 아마 날 모를 거야. 웃고 있는 내 모습은 진짜가 아니야.
So, before we start doing the Born-Haber energy level diagram, so perhaps you must know what we should start with and what you should end with. Okay, so for the Born-Haber energy cycle or Born-Haber energy level diagram, we will deal with solid ionic crystal. So the phase for the NaCl should be in solid. And you have to know what are the elements that forming the NaCl. So here we have sodium solid and chlorine gas molecule. And please check for the balancing. So since we have one sodium in the product, so one sodium should be in the reactant. And for the Cl in the product, we have 1 mole. So on the reactant part, you should put half Cl2. Okay, so this is the process of formation. And after that, for each of the elements here, you have to proceed with atomization or sublimation. So hence, for the sodium gas, for the sodium solid, when it undergoes sublimation, so it will form Ne gas. For half chlorine gas molecule, upon sublimation or atomization, you will get chlorine gas. So for the gaseous metal, it will further undergoes ionization energy. So hence you will get Na plus gas. And for the anion non-metal, this will undergoes electron affinity. So you will have Cl minus gas. So, meaning that in order to draw Born-Haber energy cycle or Born-Haber energy level diagram, so what you have to know is you have to start your cycle or energy level by having this formation, and you have to end your energy cycle or energy level diagram with this ion. Okay, so make sure you check your Born-Haber energy cycle and energy level and make sure you have those two in your answer. So, in drawing our Born-Haber energy level diagram, we will rely on these two informations that are our predictions that we have done just now, and also these informations that have all the enthalpy values. So in this diagram, we have planned to start our Born-Haber energy level diagram with enthalpy of formation, and you have to end with ionization energy or EA in order to get these two required ions Na plus and Cl minus. Alright, now, according to our prediction just now, or our planning, you have to start your Born-Haber energy cycle or energy level diagram with enthalpy of formation. So by looking back at this equation for enthalpy of formation, you can see that this reaction will form 1 mole of NaCl, solid. So the equation will start from the elements to form NaCl. And since this enthalpy of reaction is negative 411 kJ per mole, meaning that this reaction that having negative enthalpy will be drawn as pointing downwards in our energy level diagram. So in energy level diagram of Born-Haber cycle, enthalpy values that has negative values, okay, will be drawn as pointing downwards. And for the enthalpy that having positive enthalpy, so we will use arrow pointing upwards. So, according to equation just now, in order to form NaCl solid, this solid will be formed from its element. So, what are the elements that forming NaCl solid? We have sodium solid and chlorine gas molecule. Okay, and from the balancing, since we have 1 mole of this chlorine in the solid ionic, okay, so you have to put half, okay, in this element as well. Okay, and then you have to draw the line over here. So according to the enthalpy value just now, the value is in negative. So these two elements will react to form NaCl. Okay, so that is actually the equation in enthalpy formation. Na solid plus half Cl2 forming NaCl solid. So why this arrow pointing downwards? Because the enthalpy value of this reaction is negative. Okay, so we have done with our first planning, that is formation. So next, for both of the elements, you have to proceed with atomization or sublimation. So since we have two elements over here, you have to proceed with atomization and sublimation one by one. So for example, I would like to start with sublimation of the sodium. So according to the information over here, enthalpy sublimation of sodium is 1 mole of sodium solid forming sodium gases. And the enthalpy value is in positive. So since this reaction has positive enthalpy, so we can see that the reaction will has arrow pointing upwards. So from Na solid, after it sublimes, so you will get Na gas, and in this case we didn't do anything for Cl2, so you just have to copy back the molecule or formula. Okay, so now label the enthalpy for sodium. So this reaction will has this arrow. So why it is this arrow? Because Na solid forming Na gas, and the value is in positive, plus 108 kilojoule. Next, we go to the atomization of the chlorine. So according to atomization of the chlorine, half Cl2 gas will form 1 mole of chlorine atom gases. Okay, 1 mole of gases atom, and this enthalpy also is in positive. So in this case, again, we didn't do anything for the sodium anymore, and we will do enthalpy of atomization for the chlorine. So half Cl2 gas will form Cl gases atom, and the enthalpy value just now is 122 kilojoule, which is in positive. So again, the arrow of this reaction will pointing upwards. Okay, so we have done with the second step, atomization and sublimation. So upon sublimation and atomization, you have successfully forming the gases sodium and the gases chlorine. So next, okay, our last part in Born-Haber energy cycle or energy level diagram, you have to end your cycle or energy level with Na plus and Cl minus. So in order to do so, then we have to proceed with ionization energy for the metal and electron affinity for the non-metal. Okay, so again, we have two substances over here, gases sodium and gases chlorine. So in this case, once again, you have to do it step by step. Okay, so let's do for sodium first. So sodium is a metal, so when the metal undergoes ionization energy, okay, so when the metal undergoes ionization energy, so sodium gas will release 1 mole of electron to form gaseous ion. and the value of the enthalpy is plus 500 kilojoule. So since the value of the enthalpy is quite huge, so you have to make sure the energy gap must be bigger than the others. So ionization energy of the Na gas will form Na plus ion. So we will have gaseous ion of sodium, and this reaction will release 1 mole of electron. And again, we did nothing for the chlorine gaseous atom, so you just have to rewrite the symbol. Okay, so the enthalpy of this reaction will be positive 500. So delta H IE equals to plus 500 kilojoule. Okay, so according to our prediction, you have successfully forming the sodium ion gas. So our next task is to form the gaseous chlorine ion. So in order to form gaseous chlorine ion, chlorine gaseous atom will accept 1 mole of electron in order to form chlorine gaseous ion. And this reaction will release as much as 364 kilojoule of energy. So what we have to do next is, since the value of the Ea is in negative, so we will have another equation that having arrow pointing downwards. Since the value is negative 394, so for the sodium, since we have done with the sodium, so you have to rewrite the sodium formula. Okay, and upon reaction electron affinity of the Cl, so you can see at the top of the level here we have Cl gas and 1 electron. Okay, whereby that electron is actually being released from the gaseous sodium just now. So when the gaseous sodium undergoes ionization energy, it will release 1 mole of electron and to form Na plus gaseous ion. Okay, Na gaseous ion. Alright, so that electron release is actually will be accepted by the Cl gaseous atom just now. Okay, so upon that receiving of electron by the Cl, you will get Cl minus. So there will be no formations, or there will be no existence of the electron in this level anymore after you have done the electron affinity. Okay, and the value of the electron affinity is in negative, so we will have the arrow pointing downwards. Negative 364 kilojoule. So according to our planning, you have to end your Born-Haber energy level diagram with Na plus ion and Cl minus ion. So according to our steps over here, you have successfully forming those two ions. So the last step will be lattice enthalpy or lattice energy. So what is lattice enthalpy? Lattice enthalpy is the energy released when 1 mole of solid ionic crystal is formed from its gaseous ion. Alright, and according to our energy level diagram, you have successfully forming the gaseous ion of the ionic solid. So in this case, when these two ions combines, you will get this ionic crystal once again. So this step we call it as delta H lattice enthalpy. So in this problem, you are required to find the value of the lattice enthalpy. So how can you find the value of the lattice enthalpy? So as you can see, the flow in this Born-Haber energy level, we have formation going downwards, and we have the flow of reaction from sublimation, atomization, i.e., Ea, and lattice enthalpy. So we can see a continuous flow from sublimation until the lattice enthalpy. So according to Hess law, in order to find enthalpy of formation, it is actually the summation of all other enthalpies.
그래야 기분이 나아질 것 같아서 내일이 오면 나는 또 거지 아침부터 낯을 입고서 have to fake my